Let's start working on exam 3 review. Question number 1. Condensation is a process for which condensation is the change from gas to liquid. Or let me say, if we go from liquid to gas, is vaporization, right? Evaporation. It's an endothermic. Liquid needs heat. The reverse process, gas to liquid, which is condensation, is exothermic, right? So means delta H is negative. Also, it's a spontaneous process. The water on the bottles, on the cold bottles, you see the little drops on it. So it shows that the condensation is spontaneous. So delta G is also negative. So the correct answer would be B. Delta S and delta G. Okay, we don't have a delta G negative for delta H, so B is correct. Delta H and delta S are negative, and delta S is negative. Why? Because we're going from gas to liquid, and the entropy for gas is more than that of liquid, so delta S is also negative. So B is the correct answer for number 1. For number 2, it says the free energy change of a reaction is a measure of the excess entropy given off. No, energy change is not a measure of entropy. The energy given off to the surroundings. No, that's not. That's the heat. And the direction in which a net reaction occurs. Yes, that's the correct answer. It talks about spontaneity, non-spontaneity. So it's the direction in which a net reaction occurs. And also, it's not an increase in molecular disorder, that's entropy. And excess entropy, no. We're not talking about entropy. So free energy is just about the direction is spontaneous, non-spontaneous, and that's a measure of that. 3. The anode in a voltaic cell and in an electrolytic cell. The site of oxidation in both cells, the site of oxidation and of reduction. No, in both of them, we know that it's the measure of, it's the site of oxidation. So before we forget, for 2 we said it's the C. For 3 is A. Correct answer is A. For number 4, for which of the following processes would delta S be expected to be most positive? So when we says most positive, we need to look for the maximum difference between the S of in the molecules. So for A, you have 2 moles of solid on the left side, but you have 7 moles of gas on the right side. So it shows that you're going from solid, 2 moles of solid, to 7 moles of gas. So it has the most entropy change, and so delta S is the most positive. For B is the same, it's less, it goes from 3 moles of gas to 2 moles of gas. For C, it's going to be the least, because it's going from 2 moles of gas to no moles of gas. And for D is going to liquid to solid, so delta S is going to be less, negative. And for E is going from 1 mole of gas to only 2 moles of gas. So for A, we have the most delta S change, the most delta S positive. Question number 5. What is delta S standard at 298 Kelvin for the following reaction? Delta H and delta G are given, so it's a sign that you need to use delta G standard is equal to delta H standard minus T delta S standard. So we're solving for delta S standard, so it's delta G standard minus delta H standard divided by minus T. So it's going to be delta G 159.1 minus delta H 164.1 divided by, what is it, 298. So delta G standard is going to be 1.67 times 10 to negative 2 kilojoules. But you see all of the values are in joules per Kelvin. So multiply by 1,000. It's giving you about 17 joules per Kelvin. So A is the correct answer. For question number 6. Question number 6. When the following oxidation reduction reaction in acidic solution is balanced, what is the lowest whole number coefficient for rubidium ion? The question is rubidium plus solid plus strontium ion gives rubidium ion plus solid strontium, and we are looking for the coefficient for rubidium. So let's build the half reactions, rubidium to rubidium ion, and we have the mass balances, so we need to add just electron to the most positive side, more positive side, which is 1 electron. For strontium, it's going from positive 2 to strontium solid. Again, masses are balanced, but we need to add electrons to more positive side. You add 2, and then you don't have to add these two, but just to make sure we are doing everything right, 2 rubidium ion plus strontium, which would be E 2 electrons. E is the correct answer. For question number 7, the hydroxide ion concentration of a standard solution of copper 2 hydroxide is 4.58 times 10 to negative 7 molar. What is the solubility product constant for copper 2 ion? So copper 2 hydroxide we have X and 2X, so KSP is going to be Cu times OH negative squared, which is going to be 4x squared, which is 4 times 4.58 times 10 to negative 7 molar cubed, and it's going to give you KSP as 3.84 times 10 to negative 19. The answer is going to be B. Alright, let's move towards question 8. Question 8. What is the cell notation for the voltaic cell shown below? We see zinc is immersed in zinc nitrate, so it's zinc solid in zinc nitrate. Then we see a salt bridge. We see copper 2 ions floating in the solution. And we see a copper electron. So which one is showing that? It's D. So the answer for this question is D. It's question 8. Answer is D. Question number 9. KSP is given for PbF2 if a 0.03 molar NaF solution is saturated with PbF2. What is the Pb ion concentration in the solution? So it seems like since we have PbF2 and NaF, we have a common ion which is fluoride. So let's write the equation for PbF2. So we have a concentration X for Pb, and for F we have 2x, sorry, it's X, it's 2x, but you have a common ion which is fluoride and its concentration is 0.32. So let's write the KSP. KSP is concentration of Pb2 times concentration of F. So 4 times 10 to negative 8 is going to be X times 0.32 plus 2x squared. We normally disregard this 2x, especially KSP is small. So if you find it, X is going to be 4 times 10 to negative 8 divided by 0.032 squared. So X, which is the concentration of Pb, is going to be 3.9 times 10 to negative 5 molar. Which choice is giving us this answer? D. D is going to be the correct answer. Question number 10. Question number 10. Gold with its molecular mass 197 is plated from a solution of chloroic acid. It deposits on the cathode. Calculate the time it takes to deposit 0.77 grams of gold passing a current of 0.10 amperes. And we know that 1 Faraday is 96,485 coulombs. Okay, first we need to know the number of electrons that is exchanged. How to find the number of electrons? We know that this is hydrochloric acid. It is supposed to change to solid AU. So let's find the oxidation number of gold here. Oxidation number of gold on the right side is 0 because we're dealing with metal in its most stable state. But here we have positive 1 for hydrogen plus X minus 4 times negative 1 for chlorine is equal to 0. So the oxidation number for chlorine is 3. So 3 moles of electrons, going from 3 to 0, 3 moles of electrons. So start with 0.77 grams of gold. 1 mole of gold is given 197 grams, and 1 mole of AU can transfer 3 moles of electrons. 1 mole of electron is 96,485 coulombs, and 0.10 amperes means 0.10 coulombs in second. If you look at the answers, they are given 3 of them in hour and 1 of them in minutes. So most likely it's in an hour. So let's see. 1 hour is 3,600 seconds. So it's going to give you 3.1 hours, which is answer C. Question number 11. How many Faradays are required to convert a mole of NO3 negative to NH4 positive? So how many Faraday basically means how many moles. I mean, I just show you the shortcut. If you calculate the moles of electrons here, the oxidation number for nitrogen in each of them, you will find the answer. Here the X, which is oxidation number of nitrogen, plus 3 times -2 is equal to -1. So X is +5. Here X plus 4 is +1. So X is -3. What is the difference between +5 and -3? 8. So you have 8 Faradays, which is in answer E. Don't forget, the Faradays are equal to the number of moles, the coulombs that each mole of electron can move. When we say how many Faradays means how many moles of electrons. Okay, now question number 12. We're supposed to rank the following metal sulfides in order of increasing molar solubility in water. Increasing molar solubility in water means by increasing the KSP. The higher the KSP, the more the molar solubility. So which one has the smallest molar solubility? From the smallest, or let's say lowest solubility, means smallest KSP, towards highest solubility, which means largest KSP. Okay, now which one has the lowest solubility among all of these compounds you see? The KSP value is the one with 10 to -52, which is HGS. What is next? The next less soluble small KSP is CUS. After that you have COS. Then you have 10 to -18, which is FES. And the largest is MNS. So which one of these answers gives you this trend? Isn't it B? 13. Question number 13. What is the change in entropy when 0.802 grams of silicon is burned in excess oxygen to yield silicon dioxide at 298 Kelvin? The reaction is this. Delta standard is -182.4 joule per Kelvin, and it should be mentioned it's per mole. Okay, So you need to find out how much of a mole is 0.802 grams of silicon, and then multiply it by this delta S standard. So let's do it. 0.802 grams times 1 mole is almost 28 grams, and 1 mole is 182. You can disregard the negative because you know that in thermodynamics, negative is or positive, they are just the signs for direction, which is 5.2 joules per Kelvin. Which one is the correct answer? D. Okay, 14. 14 is saying that a gas absorbs 0 joules. So Q is 0 joules of heat, then performs 99.5 joules of work. W is 99.5 joules of work. But the system is performing the work. Don't forget, when system performs the work, the sign for W is negative. Make sure you know the sign for Q and W really well. So what is the change in internal energy? Internal energy is Q plus W, which is 0 minus 99.5, and it's minus 99.5. Not knowing the sign will throw you off to the wrong answer. But so for 14, we have A as the correct answer. We are halfway done. Okay, in the following electrochemical cell, what is the role of platinum? Just look at the cell notation before answering. When you look at the cell notation, you will see there is platinum at the end. The platinum serves as the anode. The oxidation of Fe2 takes place at the surface of platinum as the cell discharges. Let's write the cell notation. And you have Fe2. You have the solution of both, and PT. So shows that, which side is it? It's the anode, right? And which side is this one? That's the cathode. So in the cathode, what happens? The reduction happens, right? So C is saying the reduction of Fe3 takes place at the surface of platinum as the cell discharges. So C is the correct answer because the reduction happens in cathode. The key was that. That's all, the reduction. Number 16, which of the following is true for the reaction NH3? At negative 33 degrees Celsius, a normal boiling point for ammonia is apparently minus 33 degrees Celsius. So at this point, seems like you have an equilibrium, right? For equilibrium, delta G is what? What is the value for delta G? I'm sure you would say at equilibrium, delta G is 0. So delta G is equal to delta H minus T delta S. This is going to be 0. So delta H is going to be T delta S, and it's given in choice C. Question 17. An ideal fuel for the controlled jet of a space vehicle should decompose with when we have a fuel for the space. Do we need somebody to give it energy constantly? No. So we need a spontaneous reaction. So delta G must be negative. So we are either working on choice, answer choice C, D or E. The difference between D and E is that delta H is positive endothermic for D, but delta H is negative or exothermic for E. We need an exothermic reaction to be both favorable for spontaneous reactions. So E is the correct answer for question number 17. Question number 18 has given us two reactions and two electrode potentials. Which of the following species is strongest reducing agent? We are looking for reducing agent. When we have a reducing agent, the atom, the element is oxidized itself. Oxidation happens where? In anode, right? And so we have to have more negative potential, standard potential for the electrode. So which one has the most negative? Isn't it manganese? Yes. So D is the correct answer. Manganese. Most reducing agent, which is oxidized itself. So manganese is oxidized. The difference between manganese, is the correct answer. The difference between manganese, you might say, how about manganese ion? Why didn't you pick manganese ion? We say it should be oxidized. Is manganese ion oxidized? No. This side shows the reduction, but this side shows the oxidation. So which one is oxidized? Manganese. So you choose manganese. The difference between A and D is that. Number 19. Which of the following salts has the lowest molar solubility? So lowest molar solubility means lowest KSP. Which one has the lowest KSP? The ones with 10 to negative 10, but you have 4 of them. So you go with the one that has the lowest numerical part. So it's 1.1 times 10 to negative 10, which is E. BaSO4. Question number 20. For the reaction of carbon monoxide with hydrogen, delta G standard is given. We're looking for Kp of this reaction. The relation between delta G standard and Kp is delta G is minus RT ln Kp. So ln Kp is minus delta G over RT is 13,457 joules is given, right? And because we want it in joules, and we need to change it in joules. Why? Because the unit for R is it joules per mole Kelvin, and T is 700, right? So ln Kp is equal to 2.312. So Kp is going to be 10.1. Which one is the correct answer? 10.1 B for question number 20. Question number 21. A saturated solution of which of the following salts will have the highest molar concentration of chromate? The one that has the highest KSP value, means the one that has more molar solubility. The highest, you need to look for the highest KSP. You need to be able to interpret the questions. When we have the highest molar concentration of chromate ion, CrO4, highest concentration of chromate ion, means we have the highest solubility. So we need to look for the highest KSP. Which one has the highest KSP? The one that has the least negative exponent, and it would be A. CrO4. Okay, question number 22. How many moles of electrons are produced from the current of 17.6 coulombs per second in 3.20 hours? So we have 3.20 hours. We need to change hours to second. 1 hour is 3,600 seconds, and we are looking for the moles of electrons. 1 mole of electron is 96,485 coulombs. So we can cancel this, and it will give you how many moles of electrons? 2.10 moles, which is choice D. Question number 23. When the following oxidation reduction reaction in acidic solution is balanced, what is the lowest whole number coefficient for hydrogen ion, and on which side of the balanced equation should it happen? So you have no choice but to start balancing this equation. So let's do this. S2O8 to SO4. Seems like if you put a 2 in front of this, you will balance all of the masses. Now balance the charges. -2 and 2 times -2, -4. So you need electrons on the more positive side, 2 electrons. So you will have positive -4 and -4. For the other side is NO. Changing to NO3 negative. N and N the same, but 3 oxygens and 1 oxygen in acidic solution. And that doesn't matter. In acidic or basic, you need to add water molecules. You have to add how many more? Two water molecules, because you need 2 more oxygens. But now you have 4 hydrogen ions. But you are not done yet. You need to balance the number of electrons first. You have 2, and here you have +4 and 1 +3 plus 3 electrons to balance it with 0 here. Now you have 2 electrons and 3 electrons. You cannot add them up to each other, so you need to multiply it by 3 and multiply this one by 2. You can stop here, because at this point you can add these 2 equations to each other and write down the final equation. So 2 times 4 is 8 hydrogen ions, or if you have time, feel free to add them up. So you have 8 on the product side, so you have it in choice B. Okay, we are getting close to the end. Question number 24. In question number 24, consider the following reaction, cell reaction. 2 Hg+2 plus H2. You have 2H plus Hg, 2 plus, and the potential, cell potential is 0.92 volts. Under standard state conditions, what is the value for E standard for this? So hydrogen acts as what? Its oxidation number changes from 0 to +1 here. So it's been oxidized. This is anode. So this is going to be your cathode, right? If E of the cell is cathode minus anode, what is the potential for hydrogen? 0. You need to know that. This is nothing difficult. So E of cell is going to be equal to E of your cathode, which is the same 0.92 volts. Where do you see it? In choice E. Even without solving anything, you know that. For hydrogen, 0. That's it. Question 25. I'm not going to write everything about all the equations because it's much easier than that. It's giving you some equations with the electrode potential. It says, under standard state conditions, which of the following metals will reduce Hg to Hg here? Will make Hg2 happen, but will not reduce cadmium. So if it's going to reduce, the element must be oxidized itself. So if you just look at the list, you see that Sn is between these two. So it will be oxidized, will reduce this, but it cannot reduce cadmium. So easily you can find out it's Sn or answer choice E. Anode must have more negative potential. Question number 26. Arrange the following reactions in order of increasing delta S standard value. Number 26. So delta is increasing. So for equation 1, delta S is 0, right? Because the number of gas molecules is the same. So for 1 is the least. We are going from the least to the most. Equation number 2, you're going from 1 mole of solid to 1 mole of gas and to liquid, 2 moles of liquid. And equation 3, you are going from 1 mole of solid to 1 solid, 4 moles of liquid, and 1 mole of gas. So between 2 and 3, which one will have a more positive entropy? Which one is going to have more disorder? Of course, it's the equation number 3 is going to produce 1 mole of gas. So the answer should be A, 1 less than 2 less than 3. Question number 27. For a reaction that has an equilibrium constant of 6 times 10 to negative 9, which of the following statement must be true? So it's about delta G and delta S. We know that there is no relation between delta H and equilibrium constant. So it's about delta G and also no delta S. So delta G is minus RT ln K, right? So K is given. Calculate ln K, it would be 22.5. So minus RT 22.5, so delta G is less than 0, which is negative. So delta G negative. The answer is D. Question number 28. If the value of E standard for a cell is 2.10 volts for this reaction, F2 gas plus 2Fe positive 2 aqueous gives 2Fe 3 aqueous plus 2 fluoride aqueous, and the potential, cell potential is 2.10 volts, then what would be the potential for this? Okay, the answer to such questions is normally much easier than what you think. Look at the relation. There is definitely a relation between these. You see first, as if like this equation is flipped. So first of all, the E is going to be with a negative sign, right? And seems like besides flipping, this has been divided by 2. So divided by 2, so you will have 1.05 volts. Which one is showing that? E. Question number 29 is asking the cell potential of an electrochemical cell with the cell reaction is 1.607 volts. What is the maximum electrical work that we get when 2 moles of aluminum is consumed? So maximum work is minus NF E standard for cell. And if you do the balancing for this reaction, break it to 2 half reactions, N is going to be 6. Then I want you to definitely do that half reaction method balancing. Then you will find it out. So W max is going to be minus 6 times 96,485 coulombs times 1.6 joule per coulomb. So W max is going to be minus 9.3 times 10 to the 5th joules. Which choice is giving you this answer? It seems like D is the correct answer. Minus 9.3 times 10 to the 5th. D is the correct answer. And question 30, it does not need any calculations. It is giving you the aluminum hydroxide, and is asking for how to write the solubility product expression. Al positive 3 plus 3OH negative. So you will write down KSP as concentration of Al. So which one is giving you the answer? A. Okay, I hope this review was useful. Good luck with the studies and your exam.